All right, here are solutions to perfect problem 6 for Math 251. In the first question, we're asked to find a third-degree polynomial, and it gives us some information about the polynomial. So I think the easiest way to do this is set up your polynomial. It tells us the leading coefficient is 1. So since it's third degree, we got 1x cubed plus, and then we don't know what the coefficient is in front of the x squared term. So I think it'll be helpful to put in a little placeholder there, ax squared. Similarly, bx and c. So here's kind of a generic third degree polynomial with leading coefficient 1. What we got to do is figure out what a, b, and c are. But fortunately, it gives us some information to figure that out. So the information it gives us is about relative maximums and relative minimums. A polynomial function has a relative maximum or a relative minimum when the first derivative is equal to 0. So we can take the derivative of this guy. The derivative of x cubed is 3x squared. The derivative of a times x squared, a is just a constant, so you just leave it alone. Derivative of x squared is 2x, so we get 2ax. Derivative of bx, because b is a constant, is just x. And derivative of c is 0. So this right here is our first derivative. And we know that this thing equals 0 when x equals -5. And when x equals 1/3. So, see, I guess what you could do is you could say, all right, that means that -5 and 1/3 are roots of a polynomial. If -5 is a root of the polynomial, then x minus -5 or x plus 5 is a factor of the polynomial. Similarly, if 1/3 is a root of the polynomial, x minus 1/3 is a factor. So the polynomial f prime of x here is similar to this right here. Maybe I shouldn't put equals. But there's one problem. Our leading coefficient should be 3. And if you FOIL this polynomial out, what you'll get is a leading coefficient of 1. So in order to make that leading coefficient be 3, or sorry, to be 3 here, we'll need a 3 right here. So really what we have is this must be f prime of x. That is, f prime of x must be equal to 3x plus 5. That's using this fact. And times x minus 1/3 using that fact. And because the leading coefficient is a 1, we need to put a 3 up here. Because the leading coefficient of the derivative has to be a 3. So anyways, here's our polynomial right here. So by looking at this thing, we can figure out what a must be and what b must be. It's hard to tell when it's in this form, but if we FOIL this all out, we can do it. I think the easiest way to do it, to get rid of the fractions, is you could distribute the 3 to the x minus 1/3 here. So you get, this is the same as x plus 5 times 3x minus 1. And now if we FOIL this all out, x times 3x is 3x squared. 3x times 5 is 15x. -1 times x is -x, minus 5. So what we get is that the first derivative of the polynomial we need is 3x squared plus 14x minus 5. In other words, a must be equal to, well, let's see, 2ax must be equal to 14x. So maybe 2a must be 14, so a must be 7. And b must be -5. So what we figured out is that our original polynomial, maybe I switch colors here, so f of x must be equal to x cubed plus 7x squared minus 5x plus c. We still don't know what c is yet, right? We figured out a and b by looking at the derivative, but we don't know what c is. But we can figure that out because we know that when x equals -5, for example, the height of the polynomial has to be 74. I wonder if that's easier to use the fraction one. I guess you could use either one. I'm going to use this fact. I'm going to say f of -5, which is -5 cubed, plus 7 times -5 squared minus 5 times -5 plus c. It's got to be equal to 74. So I have this expression here. I only have one variable in it, this c, so I can solve for that. Negative 5 cubed is negative 125. Negative 5 squared is positive 25. And when you multiply positive 25 times 7, you get 175. Negative 5 times negative 5 is positive 25. And then plus, negative 5, good. And then plus c, that's got to be equal to 74. So let's see here. This is saying 200 minus 125, 200 being 75 and 25, minus 125 plus c equals 74. 75 plus c equals 74. C is equal to negative 1. So we figured out that our polynomial, do I rewrite it? I don't know where to rewrite it. F of x is equal to, maybe I'll switch colors again. So f of x equals x cubed plus 7x squared minus 5x minus 1. Whew, all right. And then part 2 says, okay, this polynomial you just figured out, when is it concave up? Okay, it's concave up if its second derivative is positive. So let's figure out what its second derivative is. Well, first of all, its first derivative is 3x squared plus 14x minus 5. Easy enough to take the derivative of a polynomial. Similarly, we could take the derivative of the second derivative of the polynomial. The derivative of 3x squared is 6x. Derivative of 14x is 14. So we want to know, when is this thing concave up? It's concave up if f double prime of x is greater than 0. That is, if 6x plus, that doesn't look like a 6. If 6x plus 14 is greater than 0, that is, if 6x is greater than negative 14, or if x is greater than negative 14 sixths. Another way of saying negative 14 sixths is negative 7 thirds, or negative 2 1/3. So the polynomial is concave up when x is greater than negative 7 thirds. In interval notation, from negative 7 thirds all the way up to infinity. What and where are the absolute max and absolute min of this polynomial if you restrict the domain to negative 10, from negative 10 to 0? Okay, absolute max or absolute min is going to come at a critical value or an endpoint. So maybe I write that in blue. Absolute max slash min happens at a critical value. We know what the critical values are, as given to us in the problem. Negative 5 and 1/3. Negative 5. So here's my x values, negative 5 and 1/3. Okay, that's written horribly. Let's try it again. Critical value when x equals negative 5 or x equals 1/3. And we know that at negative 5 the height is 74, and at 1/3 it's negative 2. So here's my critical values. But it might not be at a critical value. It could also happen at an endpoint or at an endpoint. But fortunately, the endpoints are given to us. X equals negative 10, x equals 0. And so we can figure out what the corresponding y values are by looking at, leave it in frame here, f of x. F of x is x cubed plus 7x squared minus 5x minus 1. So when x equals negative 10, we get, maybe I'll write this here, f of x equals x cubed plus 7x squared minus 5x minus 1. So we're going to have to figure out what is f of negative 10. That's negative 10 cubed plus 7 times negative 10 squared minus 5 times negative 10 minus 1. Negative 10 cubed is negative 1,000. Negative 10 squared is positive 100. You multiply it by 7, you get 700. Negative 5 times negative 10 is 50 minus 1. So 750 minus 1,000 is negative 250 minus 1, negative 251. And f of 0, if you plug in 0 everywhere, just get negative 1. So now what we got to do is look at these values right here and figure out which one is the absolute maximum and which one is the absolute minimum. Well, let's see, it looks like the lowest one is this guy right here. So let's switch colors. This one is my absolute minimum because negative 251 is less than negative 2, negative 1, and 74. So my absolute minimum happens at x equals 10, negative 10, and it's equal to y equals negative 251. And my absolute maximum is this top guy here. Because 74 is greater than negative 2, negative 251, or negative 1. Write that there. So I guess that's the end of the problem. Here's the absolute max, here's the absolute min. So that's it.